Hello again, and back to Trig. Today I'm going to do these two homework problems with you because I think they are the most important of all your homework in this section. I will remind you of the definition of the 6 trig functions. These are the definitions that I use. I think they're the most versatile and the most general. I hope you've memorized them by now. Let me point something out here in these formulas. R has to be a positive number in all of these definitions, because r is the radius of the circle that the point x comma y lies on. Alright, problem 1. Where is theta if sine is positive and cotangent is negative? The two formulas that are relevant here are the sine formula and the cotangent formula. So let's first use the fact that sine is positive. Y over r is positive. This implies, that's what double arrow means, implies. This implies that y has to be positive, because the only way a fraction can be positive is if the numerator and the denominator are both negative or both positive. But since r is positive, y is positive. Now we go to the cotangent information. Cotangent is x over y. Since that's negative, that's given in the problem, x has to be negative because we already know from our previous observation that y is positive. So, where we stand is that x is negative and y is positive. Looking at the 4 quadrants, if y is positive, then we're either in quadrant 1 or 2. We can't be in 3 or 4. But if x is negative, that narrows it down. We've got to be in quadrant 2. So theta lies in quadrant 2. All right, next problem. This problem actually involves that type of analysis that we just did, determining where theta is. We're given that cotangent is 7 over 24 and cosine is negative. We have to find the values of the other 5 trig functions. Okay, cotangent is positive. Cotangent is x over y. The only way that can be positive if both x and y are positive, or both x and y are negative. Now let's use the fact that cosine is negative. Cosine is x over r. If that's negative, x has to be negative, again because r is positive. But if x is negative, then we go back to this first line and we say, well, then we have to have this case. X is negative and y is negative. If x is negative and y is negative, we can only be in one quadrant, and that is quadrant 3. Both x and y are negative in quadrant 3. So the next thing I'm going to do is draw a generic angle in quadrant 3. Here it is. I've got a generic angle in quadrant 3, and I'm going to label the x and y coordinates of this point here, where this terminal side of the angle meets the circle. Since x and y are both negative, we know that even though cotangent is positive 7 over 24, we're going to have to rewrite that as negative 7 over negative 24 to determine x and y. X is negative 7, y is negative 24. I hope that makes sense. Just because cotangent is x over y and that's positive doesn't mean that x and y that your angle is in quadrant 1 with both x and y positive. The other option is you're over in quadrant 3 with both x and y negative. All right, and finally we have to determine the radius of that circle r, and we'll do that using Pythagorean theorem. R squared is x squared plus y squared, which is negative 7 squared plus negative 24 squared, which comes out to be 625. So r is plus or minus 25, the square root of 625, but since r has to be positive, r is positive 25. Now we have everything we need to write down the values of the other 5 trig functions. Here we go. Sine is y over r, negative 24 over 25. Cosine is x over r, negative 7 over 25. Tangent, y over x, negative 24 over negative 7 is 24 over 7. Cosecant is r over y. 25 over negative 24, we typically don't leave the negative in the denominator, we pull it out front. We write that as negative 25 24ths. Same with secant, pull the minus out, negative 25 over 7. And finally cotangent, I wrote the cotangent down, but of course that was given to us, 7 over 24. Okay, I hope that helps. These are really important problems, so spend some time on them. Bye.